Let's talk about the longevity of conductors. There are several aspects to longevity. There's the component level longevity, there's the system level longevity, and there's also longevity related to extreme circumstances. So let's talk about the components. You have vulnerability for example, in a composite core conductor, the composite material itself, especially the organic matrix material. And then you have the aluminum. TS conductor does have the combination of carbon fiber composite, aluminum. So galvanic corrosion normally is a topic that might come up. In TS configuration, the aluminum encapsulation layer is the barrier against galvanic corrosion itself. The reason for that is because galvanic corrosion requires three elements. Materials of different electrochemical potential coming together, and there's electrolytes like moisture or water at the interface, and you have oxygen readily available at the interface as well. When we have the aluminum encapsulation, it keeps the moisture out, it keeps the oxygens out. So you are eliminating 2 out of the 3 conditions already. And if you remove even 1 out of the 3, you will not have galvanic corrosion. This is why TS conductor has galvanic corrosion prevention mechanism already designed in. In terms of the degradation on the composite matrix itself, you got to look at, okay, what from the environment could cause degradation of the polymer matrix? We talked about moisture. It could come into the matrix material and plasticize the organic matrix. Basically, water is a polar molecule. It's going to come in, break the organic bond. And it will reduce TG. It will also make the composite more vulnerable to compression failure. You also have oxidation. Oxidation basically is oxygen, high temperature, and organics. You got the 3 together. That is a very bad combination. And if you can avoid that, you address that issue, you design that problem out as well. We all know that during installation, sometimes you may have bird cage, which basically have the composite core exposed to the external environment. And UV ozone from corona could play a very detrimental role in terms of longevity of that composite core for the exposed sections. With the aluminum encapsulation from TS, we completely eliminate that issue as well from product design. Let me talk about the system level in terms of longevity. Aeolian vibration is one that we have to pay attention to, which is really a fatigue issue of the aluminum strand when you have wind blowing at the conductor. With trapezoidal aluminum strand and annealed aluminum, you have the ideal condition for self-damping. Why is that? The annealed aluminum allows the aluminum strand in the TS conductor to basically creep and then relax its tensile stress to the composite core. So you have aluminum strand that's going to have significantly less tensions or even get to a stage where it's tension-free. So they are readily able to dance, which is the proper way of consuming wind energy. And the other mechanism, which is the trapezoidal configuration, which allows the aluminum strand to rub against the surface of the neighboring strand, which is really a maximal way of consuming wind energy without fatiguing the aluminum. And that's why we have much better self-damping in TS conductor configurations, and we can manage aeolian vibration better than the traditional conductor. And from a system perspective, in terms of longevity, we also need to keep in mind about the fittings, especially splice and dead ends. What is unique about TS is we use crimping approach to achieve splicing and dead ending installations. And in the TS conductor, when we complete the crimping, we actually have a solid hunk of metal around our composite core, and we have the composite core preserved with full integrity while it is surrounded by 100% dense aluminum. What this gives you is, even if you did not have high temperature filler compound that normally is required for a traditional conductor, we do not allow an ingress pass for moisture or oxygen to go inside the fitting, which is really a limiting factor for the fitting life as well. And talk about the longevity in extreme weather events. In wildfire, for example, TS conductor, it has low sag, and the aluminum is already fully annealed. When you have a fire that are passing through the transmission line, it will have minimal effect on the TS conductor because it's not going to sag down, and the aluminum is already fully annealed. So it's going to survive better. If you have extreme wind event, the TS conductor has a compact design. It's also got a smoother surface. So you will have less tension to the structure and to the conductor, and less wind load to the conductor itself. So you have a greater margin of safety there as well. And if you have ice load in the conductor, we actually, a compact design means you have less ice building on the conductor with the same thickness. And number two, our conductor always have a higher strength compared to the conventional conductor. So it's got a much bigger margin of safety to handle the extreme weather that might be coming from climate change.